Hey folks, this is a titration problem with a slightly different twist. In this case, what we have is a quantity, 25 milliliters of hydrochloric acid sitting in our flask, and we're titrating the hydrochloric acid with sodium hydroxide. So we have a known concentration of the hydrochloric acid in the flask, but an unknown concentration of the sodium hydroxide that's in the burette. So it's a little bit of a reverse of the typical titration problems we've seen in the past, but the principles are basically the same. First, we calculate the moles of our known, which is hydrochloric acid. And in this case, we know the concentration and we know the volume. So to calculate the moles, we take our concentration, 0.1528 moles per liter, and we multiply that by the volume in liters. Well, we've got 25 milliliters, so we're going to have to do a unit conversion. So I've got 25.00 milliliters, but I know there are 1,000 milliliters in a liter. So I use my conversion factor of 1,000. Milliliters will cancel out, liters will cancel out. So I'm going to be left with an answer in moles, which is 0.00382 moles of HCl. That's it. All right, part B. And again, that's all we were asking for in part A is the moles. Part B wants to know how many moles of sodium hydroxide we're going to have to add to neutralize the HCl. So remember, we're adding the sodium hydroxide from the burette, but this is a simple one-to-one relationship, HCl plus sodium hydroxide, simple acid-base reaction. With a sodium chloride salt if we were to evaporate it. All right, so it's something that we've talked about several times. So the one-to-one relationship means, okay, that's easy. If I've got 0.00382 moles of HCl, boom, that means at neutralization, at the equivalence point, I'm going to have 0.000382 moles of sodium hydroxide. All right, very good. Now, what's the molarity? I want to know the concentration. Well, molarity again is moles per liter. I know the moles. All right, that's the number of moles of sodium hydroxide. I need to know the volume. All right, so what's the volume? We need to figure out how much we added. So we started out with 2.21. Right? Let's just go back up here. Oops. We had 2.24 milliliters. I'm sorry, I said 2.21. So we had 2.24 milliliters initially, and the final reading was 39.21. So the volume added was 36.97 milliliters. All right, very good. All right, so now we just figure out the concentration. We take our moles, 0.00382 moles divided by 36.97 milliliters. Now, we do need to make our unit conversion to liters in order to get molarity. So we use our relationship 1,000 milliliters per 1 liter. All right, and we get, and again, just checking that, milliliters are going to cancel. We're going to be left with moles per liter for our final units. So we do that calculation and we get 0.1033 moles per liter. All right, that's it. That is the concentration of our unknown sodium hydroxide. Let me know if you have any questions.